All right, happy fall break, everybody. We're going to go ahead and jump into chapter 5. So we'll start with 5.1. It's all about inverse functions. So an inverse relation, all you guys have to do is switch the x and the y. So when you look at this first example, we have h. It's this set of ordered pairs. There's 4 ordered pairs. The inverse of h, literally we're just switching them. So negative 8 comma 5 becomes 5 comma negative 8. 4 negative 2 becomes negative 2 comma 4, etc., etc. Just switch the x and the y. Please do not touch the signs. They don't change positive and negatives. They literally just flip-flop places. So consider the relation G given by those 3 ordered pairs. We're going to graph the relation in one color, and then we're going to find the inverse and graph it in the other. So we'll go ahead and plot these points. 2, 1, 2, 3, 4. Looks like we have a point roughly there. 1, 1, 2, 3. Negative 2, 0. Okay. So we've got those 3 ordered pairs. And then if we're going to do the inverse, so the inverse of G, I'm going to go ahead and write those ordered pairs out. Just switch the x and the y. And now let's go ahead and plot those. So we're going to go to 4, 2, 1, 2, 3, 4, up 2, 3, 1, 1, 2, 3, up 1, and 0, negative 2. Right there. So that would be the graph of G in blue. The graph of the inverse G is in red. And then one thing I want you guys to take a look at is that inverses and their functions are always going to be reflections over the line y equals x. And so that line y equals x has 0 as its y-intercept and then a slope of 1. So I'm just going to go ahead and try to dot that line in the best I can on this smart board. Uh-oh, got a little messy right there. Okay, well, pretend like that line looks really great. That is the graph of the line y equals x, and hopefully you can tell that the blue and the red line are just reflected over that line. So anytime you need to graph, sometimes doing the reflection is easier than trying to find all your ordered pairs and switching them. All right, example number 2. Find an equation for the inverse of y equals x squared minus 5x. So in inverse, we just switch the x and the y, and it's the same thing when we're writing the equation. So I'm just going to take the y value, replace it with x, and x with y. So this becomes x equals y squared minus 5y. You are done. So that's all it's asking us to do. That would be the inverse. Now, obviously, that would be tough for us to graph because it's not y equals, and we'll talk about that later. Okay, so these tables that are down here, I'm going to go ahead and save those to talk about in class, but we will go ahead and fill in the blanks on these. So a function is one-to-one if different inputs have different outputs. That is, if A does not equal B, then f of A does not equal f of B. So a function is one-to-one if you were to plug in 2 different numbers and get out 2 different values. So if I were to plug in the number 2 and I get out a 5, and then I'm to plug in the number 7, and I get out a 10, that would be a one-to-one function because when I put in 2 different numbers, I get out 2 different numbers. I'll show you what that looks like in an example when we come back to class, but hopefully that makes a little sense. We can reverse this as well. So, or a function is one-to-one if when the outputs are the same, the inputs are the same. So if the outputs are equal to each other, then we put in the same number. And again, I'm going to share that example in class because I do feel like it's a little bit tricky to understand. But let's talk a few more fill in the blanks here. Flipping onto the back of your page. Inverse notation. When we are talking about inverses, you're going to see it as f inverse of x. That is not an exponent. That means you're talking about the inverse. Okay, so if a function is one-to-one, then its inverse is a function. the domain of a one-to-one function is the range of the inverse. And the range of your function is the domain of the inverse. So remember in that first example where we literally just switched the x and the y's? Well, we're doing the same thing with the domain and the range. Domain is your x's, range is your y's. And so when we're flipping the x and the y's, our domain and range also flip with each other. A function that is either increasing or decreasing over its entire domain is guaranteed to be one-to-one. So something linear is going to be one-to-one. Some other ones as well. Something cubic would be one-to-one, but we'll look at some examples that are not. Okay, so I'm going to skip example 3. That's really talking about how to tell if something's one-to-one, and like I said, I think it's a little bit tricky, so I'm going to save that guy for class. But we'll talk about how to tell graphically if something is one-to-one. So the horizontal line test, something new. We had previously talked about the vertical line test. The vertical line test tells us if something is a function. So the vertical line test tells us if a graph is a function. Well, the horizontal line test tells us if the inverse is a function. So the vertical line test tells us if our original guy is a function. The horizontal line test will tell us if our inverse is a function. So let's look at these examples down below. I'm going to skip those 3 that I wrote in between and look at example number 5. So this straight line, we're going to do the horizontal line test, meaning that if I draw an infinite amount of horizontal lines, does it cross at more than one point? No, it never, ever, ever will with this one. So this is one-to-one, and the inverse is a function. So if I were to take that line and reflect it over the line y equals x, we would get another function back. Let me show you what that looks like on this guy here. So on example B, I'm going to try to draw in the best I can the line y equals x here. Then if this guy were going to flip over that line, so that's going to look like, we're going to take that that parabola and we're just going to flip him, so it'll be on its side, so this will roughly look like that. Well, the line or the parabola in red is not a function. So when we do the vertical line test on the red, we can easily tell it's not a function. Well, we don't have to graph it. That's the whole point of this horizontal line test, is if we take the guy that we were given, the original function graphed in black, and we were to draw horizontal lines, we can tell it crosses at more than one spot. So we would say that this is not one-to-one, and that implies that the inverse is not a function. You don't have to graph it. Like I said, the horizontal line test takes care of itself. All right, looking at example C, if you were to draw horizontal lines across this function, it will never cross at more than one point. So yes, this is one-to-one, and the inverse is a function. On this last example, we can see when we draw a horizontal line, it crosses at more than one point. So this is not one-to-one, and if we needed to graph the inverse function, we know, or the inverse, we know it would not be a function. All right. Flip into that last page. Finding a formula for an inverse. There's 4 steps here, so we'll just fill those in and then we'll show you how it looks. You're going to replace f of x with y. You're going to interchange or switch x and y. You're going to solve for y and then replace y with f inverse of x. All right. Let's get some room on example 6 and 7 here. So this is linear. Something linear, yes, we know it is going to be 1 to 1. And think if it's a straight line, that horizontal line test will pass, so we know it's 1 to 1. We're going to find the formula for its inverse, so we're going to follow those 4 steps. Replace f of x with y. Switch x and y. Solve for y. Let's add 3 to both sides. Divide both sides by 2. And then finally, replace y with f inverse of x. And then we can graph the original function and its inverse. So I'll graph the original function in black. F of x is 2x minus 3, so we know we have a y-intercept at negative 3, and then a slope of up 2 over 1, up 2 over 1, 2 over 1. Okay, we'll get a line roughly looking like this. Now, if I did not want to have to actually graph the one in red, remember I can put that line y equals x. I'm just going to go ahead and dot that line in here. And then I could flip all of the points over that line. So that would look roughly, and I'll graph that one in red. It's a little bit hard for me to show you on here because my Smartboard doesn't graph super accurately, but he'd be at, let's take this y-intercept at about 1.5 and then up a whole over 2. Oops, I got a little messy. But anyway, he's going to look something close to this. So he'll be crossing over that blue line at the very, very top right corner and then getting further away in the bottom left-hand corner. All right, I'm going to save example 7 to do in class with you. Let's go ahead and talk about inverse functions and composition, and then I'm all done. Okay, so if a function is 1 to 1, then f of f inverse of x will equal x. So if you put the inverse into your original and simplify, you will get out x. And if you put the original into the inverse, you will also get out x. And you have to do both of them. So let's look at example 8. Let me show you how this looks. So let's start with f of f inverse of x. I'm going to take the inverse function and I'm going to put it into my original function. So that'll look like 5. Instead of x, I'm going to replace it with x minus 8 divided by 5 plus 8. 5 times x minus 8 over 5, the 5's cancel, so that leaves me with x minus 8 plus 8. Well, negative 8 plus 8 is 0, so I have just x. I do have to do the opposite direction as well. So now we're going to take f inverse of f of x. So I'm going to put the original function into the inverse. So that one's going to look like, instead of x on top of that fraction, it will be 5x plus 8 minus 8 divided by 5. So on top there, with the parentheses, there's really nothing I can simplify, so I can just get rid of those parentheses. 8 minus 8 is 0, so I have 5x over 5, which is just x. And again, you do have to show it both directions, and they both have to give you x. So yes, we know that this function is 1 to 1. All right, you guys, hopefully that gave you a little bit of a sneak peek on 5-1. I'll cover the rest in class on Monday after fall break. Enjoy the rest of your break.